In this recording, we're going to look at the units 3 and 4 from last year. So some of the major ideas we're going to look at are quadratic functions, how to solve the equations related to quadratic functions, and solutions that could be imaginary. Okay, we're going to introduce complex numbers. We're all going to look at polynomials and all the algebraic and graphical connections we can make with polynomials. So the first question we're going to look at is 6 on the first final exam review that we're looking at here. So we've got a parabola and we want to find the x-intercepts, and we want to find the kind of exact values of them. So we're going to look at an algebraic approach. So this would be a parabola, right? It's something like this. It's an upward facing parabola. We want to find those places where it crosses the x-axis. So of course those places would be when y equals 0. So anytime you say x-intercepts, you can think, okay, I don't know what the x is of that point, but I know the y has to be a 0. So we're going to replace y with a 0, and then we're just going to do the algebra here. So we're going to solve this with our quadratic formula. The way I like to do it, if you know how to do this with quadratic formula, go ahead and dive into it. I think you can probably work this out. Quadratic formula is provided to you on your reference table for the Common Core Regents. Play the recording when you need help. Okay, so I'm going to go through this pretty quick. Once I know the values of a, b, and c, I'm going to evaluate the discriminant. Okay, I guess we should establish what our quadratic formula is. In my class, we always do a little song. So here's our song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Again, it's provided to you on your quadratic formula sheet, but now you have it. So we're just going to make our substitutions. And that evaluates to be 44. The way I like to do it, the reason I like to do it this way is now I've got this whole discriminant figured out. Okay? And I know there's not going to be any imaginary number because the discriminant was a positive. Okay? We can work on this square root of 44 and break that down. So that's going to become 2 root 11. Now it's just a matter of, okay, which one of these choices is equivalent to that? And I think we could see we could divide each of these terms by 4. And that's going to all simplify to be this choice here, number 2. Negative 6/4 and 2/4. Next question. We're going to skip to number 7. That is the next question, so let's go right to it. On the next page. All right, so this one says, all right, you don't know much about this function. F of x is a quadratic. Solutions are when the y value is 0. And these are them. So therefore, which could be the graph of f of x? Play the recording when you're ready. Okay, so there's only one reasonable answer here. These are imaginary roots. Okay, they have I in them. This does not have imaginary roots. It has rational roots, or real roots. I don't know if they're rational or irrational. This one only has one root, right? It just touches the x-axis in one place. Okay, it's tangent to the x-axis, to use a calculus word. Part 4 has 2 roots. Number 2 does not have any real roots. It does not touch the x-axis. So it doesn't have any real solutions to f of x equals 0. That means the roots are imaginary, and that's what we said here. Next one we're going to look at is number 8. This again is a solve for x, but it's already telling you to express the roots in simplest a plus bi form. So that's a big hint that the roots are going to be imaginary. Doesn't necessarily have to be, because we could have a b value that is a 0 and have a real number, but it's a pretty good indication that it's going to be imaginary roots. Why don't you work this out, get as far as you can, then play the recording for some help or just to check your answers. Okay, so I'm going to get all the terms over to the left side, and when I do that I get something like this. Hopefully you've tried this and gotten as far as you can. You want to just fast forward and see the answer, that's fine. You don't have to do it my way, but I like to lay out what the A, B's, and C's are, and then identify the discriminant. I'm not going to sing again for you. I know for some of you that didn't have me last year, that was a little abrupt to have a math teacher singing, but it's really the way to get that formula straight in your head. Okay, we have a negative discriminant. Remember, the discriminant is the part of the quadratic formula that goes under the square root. Square rooting a negative leads to imaginary roots. Okay, so it's coming out kind of as we thought. So negative, negative b. Again, break this down. First thing we do is take the I out. I square root of 12. Right? That's equal to I root 4 root 3. Now we know the square root of 4 is 2. The order of the factors changes. The correct way to write it is 2i square root of 3. Okay, so this is an 8 plus or minus 2i square root of 3. I'm going to divide them both by 2 separately, and then we'll have our solution. Okay, at this point, I'm hoping that number 9 is one that you can work out on your own. Again, big clue that you're going to have a negative discriminant here with the clue in the directions telling you to write it in simplest a plus bi form. Work this one out and then play the recording when you're ready. Okay. So another way to write this problem, and I'd like you to write this in the directions, is to say find the solution set. You want to be familiar with all the vocabulary so you don't get thrown off if a particular set of directions uses other wording. Okay, again, before we can identify A, B, and C, we need to be in what's called standard form, where all the terms are on the left side, all combined, any like terms are combined, equal to 0. Okay? You could get all the terms on the right side, that doesn't matter, but just get a 0 on one side. Again, it worked out to have a discriminant value of negative 12. Okay, because I already know from previous problem how to break down square root of negative 12, I'm just going to put that in because we already know it. Okay, again, these can be stored in your calculator and checked. Okay, I'm not going to go through the full process for doing this, but let's just review that briefly. You can pop that into your calculator in the home screen. Okay, we can enter the number negative 5 plus or minus, I'll just do the plus, I square root of 3. So you want to know all these tools. I is in blue above the decimal key. Okay, and then I'm going to get outside of that square root and store. Stow button is right here to the left of the 1. Stored in X. It immediately converts the square root of 3 into approximate decimal. Then I could type in the left and the right side of these to see if they agree. I can do that for all these. You want to have these tools at your disposal. Next question we're going to look at is number 12. Describe the end behavior. So this gets into our polynomials. Hey, we had a really nice unit last year on polynomials. Great connections were made. I know you forgot a lot of stuff, but we're going to bring it back here. It's really good stuff. Great connections we can make. So the end behavior says, okay, if you were to zoom way out, think Google Earth. That's what I like to think about it. So if you're looking at this from way out, you don't care so much about the in close to the origin behavior, just out at the extremes. When x gets really small, like towards negative infinity, where's the y getting towards? And the same on the other side. When x gets really big, like towards positive infinity, where's the y getting towards? Okay? Okay? So again, this is saying the same thing. As x gets really small, as I'm moving left, 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 I'm also moving in the y direction, down, 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 down. So that goes to negative infinity. In the positive x direction, as I move to the right on the curve, it gets towards negative infinity. So that's what we call our end behavior. Is the function odd, even, or neither? This isn't something we've talked a ton about this year, but it is a pre-calculus and a calculus topic. In order for a graph to be even, that would be an example like the function y equals x squared, where it's perfectly symmetric about the y-axis. That's an even graph. An odd graph would be something like the graph of a tangent. So something like this, or a graph of y equals x cubed. All right, so it was y equals x squared up here. Y equals x cubed is considered odd. It has 180-degree point symmetry about the origin. So this one doesn't have either of those. It's not symmetric about the y-axis. If I were to rotate it around the origin, 180 degrees, it wouldn't look the same either. So it's neither. Okay. It asks us to state the zeros. Well, the zeros are simply the x values that make y equal to 0. So look at that graph and write down the x values that make the y equal to 0. Play the recording when you're ready. Okay, so hopefully that was easy for you. You said, okay, at -5, at 0, and at 3. Those are x values that produce a y value of 0. And now it says, okay, express this function as a product of linear factors. That sounds pretty hard. Let's make it easy. Each one of these zeros can be turned into a linear factor. A little scratch work over here. If I were doing a solve, and I got it factored, x plus 2, x minus 7, you'd go through and you'd say, okay, that leads me to x plus 2 equals 0, therefore x equals -2. X minus 7 equals 0, therefore x equals 7. Now I'm starting with the zeros, like I have here, and I want to know, okay, what's the linear factor? So we're working backwards here. So for this factor of -5, that produces, or for this 0 of -5, that produces a linear factor x plus 5, right? If I sub in a -5 for x, I get a 0. For the 3, x minus 3. If I sub in a 3, I get a 0. Now what are we going to do with 0? Well, obviously this is, if I just multiply those two, I would get a parabola, right? Obviously this does not have just two factors. So I need here an x, because subbing in an x, that would give me a 0. Now this is subtle, but we got to get this right. Because at the 0 of 0, in other words, the x-intercept of 0, it makes a parabola-like shape, we need this to be a square. Whereas at the 0 of -5, if you were like really closely zoomed in here, it looks like a line, right? It cuts right through the x-axis. Or the x-axis. Same with the 3, it cuts right through the x-axis. It would look like a line if you were up close. But this one looks more like a parabola. It touches the x-axis and then moves back in the other direction. That's why we have a square there, and we call that a multiplicity. Okay? Finally, if I were to multiply this out, I would end up with a parabola, or a quartic, a polynomial that faces up. But this one is oriented down. So what I need is a negative in front to fix it. All right, and the really cool thing is I can check all this, right? I would type that into my y equals. I would look at the graph and I'd say, wait a second, it's hitting the zeros like I want, has that nice multiplicity, but if it doesn't have the negative sign, it's oriented the wrong way. And you're getting really good at transformations. You would recognize, hey, I just need a negative in front to reflect it over the x-axis, and you'd fix it. So it can be kind of a trial and error process. All right, 13. This is where the good stuff gets in between the algebra and the graph. Is this factor, this polynomial here, x minus 5, a factor of this polynomial? And we have multiple ways to do it. I'll show you both. One is we're going to use synthetic division. Okay? If this is a factor, it will divide in evenly. Just like if 3 is a factor of 24, it divides evenly into 24. Okay? So we could do some long division, all right? Little x minus 5, and then we do this, and then the 4x cubed, blah, blah, blah. I'm not going to do it that way. I'm going to take a shortcut here, what's called synthetic division. Okay, you can go back to your notes from last year. I have some videos on it that go through in more detail, but I'm going to show you one example of synthetic division here. So we're going to do x minus 5 and turn that into its opposite. So rather than have a minus 5, I'm going to do just a 5. Okay? Then I'm going to basically strip out the coefficients of this polynomial. Because when you do the division, you're really just operating on the coefficients. 4, -2, 8, and 10. And some of you are saying, I kind of remember this, and others of you are saying, that doesn't look familiar at all. Either way, it's okay. Note, if I had a 4x cubed and the next term wasn't an x squared, it was just like 4x cubed then -2x with no x squared, I'd have to leave a 0, leave a placeholder for where the x squared would be. Okay? All right, so if you're kind of tuned out, this is where you want to dial in. This is how we do the magic here. It's pretty easy, actually, once you understand the process. I think it'll come back to you. The 4 you bring straight down, always. Whatever that first number is, you bring straight down. Then it's repeatedly multiply and add. So 5 times 4, 20. Add. The reason we can add here is because we changed the -5 into a +5, because adding is a lot easier than subtracting. 18 here I added. 5 times 18, 90. Add, 98. 5 times 98, 490. Add, and we get a 500. Okay, and again, we said if it divides evenly, the remainder would be 0. So this is the remainder, this number on the right side. Okay, it would have needed to have come out as 0 in order to be considered a factor. All right, method 2. This is our OR. If you don't like that method, or you just want another way to put a connection in, and you should, we're going to basically turn this expression into a function. Okay? Making a connection like we did before, if x plus 2 is a factor, x equals -2 is a 0. So if x minus 5 is a factor, x equals 5 would have to be a 0, right? I would look on the table at x equals 5 and I would see 0. Okay? However, when you do that, you will see that the y value for x equals 5 is 500. And again, that makes a cool connection here. The remainder, according to our remainder theorem, is equivalent to the function value at that particular x value. So when I sub in 5 to the function, I get 500. When I divide the expression by the factor x minus 5, I get a remainder of 500. Not a coincidence. It's always going to work that way. So you can do it either way. If I want to know what the remainder is, I can just pop it in my calculator and evaluate it and avoid the division. Kind of a cool connection. Okay. The last one we're going to look at on the final exam review, and then we're going to do 2 questions off the eMath, is number 15. Okay, so for this question, we're given a cubic polynomial. Cubic means it has a leading coefficient with exponent 3. Okay? And we're given that f of negative 3 equals 0. So again, f of x, we always say f of x, right? So that's an x, and f of x is like a y. So right there we know a point on this function, okay? And therefore, what must be a factor if when I sub in negative 3, I get 0? Okay, and hopefully recognize, okay, the binomial x plus 3, if I were to sub in negative 3 for x, I would get a 0. So that must be a factor. Okay? And then it says, okay, determine the other 2 factors algebraically. Well, as long as we know what one of the factors is, we can do division. We can either do our long division or our synthetic division. I'm going to do synthetic division because I think it's easier, and I make less mistakes with easier stuff. So first, I'm going to turn the factor into its opposite. Okay, so I'm going to, because it's easier to add than it is to subtract. That's why we turn the x plus 3 into just a negative 3. Take all my coefficients, 1, negative 1, negative 44, and negative 96. Why don't you get as far as you can with this, then play the recording when you're ready. Okay, so hopefully you worked this one out. Bring down, multiply negative 3 times 1, add negative 1 plus negative 3, multiply negative 3 times negative 4, add negative 44 plus 12, multiply negative 3 times negative 32. So it always comes back to that negative 3 times whatever's on the bottom. Okay, 96. And that came out pretty nice because it adds to 0. Therefore, our remainder is 0. That means it divides in evenly, right? If it doesn't have any remainder. That's good. That's what we hoped it would be. So now I need to interpret this. Well, that's pretty easy to do. We were dividing a cubic, exponent of 3, by a linear. So therefore, we should have a quadratic, right? That's the remainder. So this turns into negative 32. Moving to the left, this is the coefficient of x. Moving to the left, that's the coefficient of x squared. Equal to 0. I can factor that out, which I'll do over here. Okay, so it said, determine the other 2 factors. Well, I can find those other 2 factors by just factoring out x squared minus 4x minus 32. So take a moment to factor that. X minus 8, x plus 4 are the remaining factors. Okay. So I want to just tuck one little additional question in here that wasn't on your sheet. So find a little space somewhere and state the zeros of f of x. So again, the zeros are the x values that make y equals 0. Okay. So we'd have something like our 3 factors. Don't forget we had an x plus 3 factor early on. and then those two we just found. It's not a coincidence, guys, and I think you know this, that there are 3 linear factors because it was a cubic, right? X times x times x makes x cubed. Hopefully that clicks for you. So just set each one equal to 0. Those are our zeros. And we can write them in a solution set notation. Order doesn't matter. Whatever order you have is fine. Okay. Want to do 2 questions off our eMath. So Unit 6 review, skip down to number 4. We have here a graph of a parabola, and we're going to use it to solve a quadratic inequality. Okay. So why don't you consider this question? Read it all up, look at the graph, look at these number line graphs, choose an answer, then play the recording. Okay, so hopefully you recognize that we're all talking about these points at -7 and +3, which happen to have to do with the factors of this, right? We have to eliminate something. So first off, because it's a greater than, not a greater than or equal to, right away I know it can't have anything to do with 3 and 4, right? Because those are filled in dots and our endpoints are not equal. Not equal to 0, it's just greater than. Okay, so I'll put some open dots right there on those places. And now the question is, well, is the solution in between those 2 points? In other words, below the x-axis, or is it beyond those 2 points, above the x-axis? Well, this is saying when this function, this expression is greater than 0. So because we replaced our y with a 0, we want when the y values are greater than 0, so up here. So then transferring that over into a number line, it looks like number 2. If you had chosen the numbers down here between those 2 x-intercepts, you'd be getting the points that give us a y value less than 0. The next question I want you to look at is on quiz number 7, problem number 2. Why don't you consider this one and play the recording when you're ready for some information. Okay, so this one has to do with transformations, right? Don't know what these functions are, but I can see that they're transformed and we have some choices. Okay. Think about the effect of that negative sign that reflects the function over the x-axis. Okay, clearly we have that going on, right? It reflects f of x over the x-axis, so I have to eliminate choice 2. And I'm also going to notice that the x-intercepts are the same. So it did not do any horizontal stretch or shrink. So that eliminates choices 1, that has a 2 inside, and choice 3, because that has a half inside, which would actually stretch it horizontally. So I'm going to look carefully at choice 4 and see if that's possible. It reflects over the x-axis, that's where the negative is, and then it multiplies it by 1.5. Okay, so this point right here maybe is at like a -1. This would be at a +1.5. Okay, that seems reasonable. Again, if this point's like at a +2, multiply that by -1.5, that would give me a -3. So that'd be way down here. Okay, that seems reasonable. I like that choice. Thanks for watching.